Hey everyone, I made this 3D Tic Tac Toe game in Babylon.js, and I just kind of want to show you what it is, how it works, and highlight a couple of the interesting code pieces. So first thing you can note is you can turn the scene however you want. We have camera controls for that, and it plays like your standard Tic Tac Toe. Once you have a winner, let's see if we can get a winner here. There we go. You can see O wins and play again, and this is HTML that is over top of the canvas, the Babylon canvas that we're using. So the HTML is actually absolutely positioned over top, and then of course you can still turn, once the game is over you can no longer click or turn the scene, but if you click play again you can restart the game and the controls come back attached, right? So I can then start the game over. O starts first this time. Okay, and you can of course click play again. So I'm interested in showing you some of the code for this and kind of how this all came together. So let's go over to the code. Babylon specific things that are interesting. So I import all as B from Babylon.js. If you look at the documentation, it likes to use Babylon in all caps, but that gets really lengthy and wordy. So I just use B for Babylon. I grab my HTML elements from my index.html file. I set a turn. These are my box coordinates, right? So each, let's go back to here. Each and refresh. Yeah, each box has a set of coordinates, right, in the X, Y, and Z plane, because it's 3D, and that's what this is. That's what this set of box coordinates are. I'd probably freeze this if I run back and refactored, because it's never going to change, right? And I actually, an interesting tidbit is I had these two flipped around, line 17 and 19, and I couldn't figure out for the life of me why this wasn't working, which is this checks for a win. And this is a bit lengthy. I would also refactor this into some smaller functions and things like that, but I was wondering why this wasn't working, and I spent a lot of time looking through the numbers and seeing, if I had my rows and diagonals right, and it turns out I did, but what I didn't have right was my box coordinates, which I just had this 1.5 and this negative 1.5 flipped, which makes a difference because it means box 6 was in box 8 spot and box 8 was in box 6's spot, right? It starts with 0, so box is 0 through 8 instead of 1 through 9. Babylon specific, in order to make a scene in Babylon, right, you need a scene. So you need to create a scene. Well, first off, you need to make an engine. So you have an engine, and you instantiate an engine, you throw in your canvas, and you give that to a variable name, you store it in there, and then you take your engine and you create a new scene and throw your engine into that and instantiate a new scene. You also need a camera and a light. And then you need, well, in my case I'm using a clear color here, which is black, and the one on the end here is the opacity, which is 1, so it's not transparent at all. It's just a fully black background, which can be seen here, right? That's what that scene.clearColor is. And then if you take out this line, your scene won't run, right? So if I do this and save, my scene won't run. Let's see. Yeah, so it'll just be blank. You need this engine.runRender loop. In my case, I stored the scene in a scene to render variable, and then you call the method render on the scene to render variable. Or if you didn't store it in a scene to render variable, you would do scene, yeah, not in caps, scene.render like this. And that would also work if you don't store it separately first. So what else did I do? I changed something, didn't I? Let me go back, Control Z. Yeah, just that. Okay, so backspace that. Yeah, so create camera and light. So to make your scene, you need the new scene. You probably want a camera and a light. Without those, you're not going to be able to see much. And a clear color. For the background, you need to run your render loop. You can also do different types of backgrounds, but for me, I just wanted a black background. And you got to have this render loop or your scene won't show. Yeah, take you down to the create camera and light functions. Create light's nothing special. Hemispheric light is like ambient light. It exists and it's there, but it's not as obvious as like a spotlight or a like a light bulb effect. But it's light that's there on the scene. It illuminates the scene. The camera is more interesting. So the camera it takes all these different arguments when you instantiate a new ArcRotate camera. The alpha is in the circle, it's the left to right of the camera. So if I'm like looking straight on at the box, if I say, in my case, I said pi divided by 4, that takes me over to a 45-degree angle, I believe to the right. And if I keep going, I get pi divided by 2, which is 90 degree, and I'm looking at the right face of the box instead of the front face. So it takes you that way around the circle, left to right. And then the beta of the circle takes you around top to bottom of the circle. So it starts at 0 at the very top, and it goes like pi divided by 2 would be 90 degrees. In my case, I did pi divided by 3, so it's kind of in between. It's above. It's not pi divided by 4, so it's not 45 degrees looking down at the target, but it's slightly lower than that. So you're still looking down, but not like as far down. So that's what that is there. Radius. So my target's at 0, 0, 0. So I'm having the camera point right at the center of the scene, and the radius is 8. So the bigger the radius, the further out the camera moves from that 0, 0, 0 target, and the further away it gets, the further its arc circle gets. And 8 is far enough that you can see the entire scene. If I refresh now that I put the render back in, hopefully it comes back. Okay, it doesn't. Did I not save? I didn't save. Let me save it. All right, let's go look again. Yeah, okay. So 8 is here, but I would wager if I put like 18, this scene's gonna go back further. So for example, if I put 18 here, save it. Yeah, okay, so the camera goes back further, and if I change that from like 8 to 2, I'm gonna put it back to 8, and you'll see it goes back. But if I put it to like 2, my camera gets really close, and you won't be able to see the entire Tic Tac Toe game. But so I have it about as close as I can without getting too close and not too far so that you can't see the scene. So that's interesting on the camera. I have a create boxes function, right? So create box makes one box. It has to be, it did have to be pickable. Not sure if it does anymore actually, but I added this is pickable true and box material white matte, which comes from the materials.typescript file, which I'll show you in a minute. Then I have this create boxes function, which it clones the first box, and here it is. It clones the first box. So we create one box with our create box function. Then we loop through, clone the box, and assign each name a kind of a box ID. And so this is the name of your box, right? When you make a mesh, you give it a name, so you can go back and you can manipulate that mesh to however you want, and you know how to get that mesh by its name, kind of like in Canvas, not in Canvas, kind of like in the document object module, the DOM in JavaScript. You give it a class or an ID, and then you access it by that class or ID. You do it with a name in Babylon. So this is the name, and then I give a name to each one here, and I set the box positions. I have a function for that, and it just aligns to the box coordinates from up here that I was showing. What else we have? Yeah, so I have a listener function, right? You have to listen for clicks on your scene. And okay, so that's interesting in the fact that I tried the actions manager. I forget exactly what it's called in Babylon, but that wasn't really working for me for just a click. So I had the scene.onPointer down. So whenever I click on the scene, I look for if the picked item, the mesh, has the white matte material, which is the pizza, and if it does, then I know that I should change it to an X or an O, right? And then I go through the game logic of changing it to the correct mesh, and then checking if there's a winner, and if there is a winner, go to the end game. If not, the turn, it goes to the next person, and it repeats. In the end game, so I turn on the visibility of the button and the the win message. I detach the controls so you can't be moving the scene around and clicking and adding things like that. New values like X's or O's when the game's already over. And then I add an event listener to the button. This function's too big. I'll refactor this, or I would refactor it if I was just going back through. Definitely refactor those. But I add an event listener to the button then, and when you click the play again button, the HTML stuff gets hidden. The boxes get reset to a white material, and we reattach the controls to the scene so that you can again play the game from the beginning. The only thing left really is the materials.ts file. In here, all I've done is I've set the emoji had to be set, the text had to be set differently than the emoji. So for example, the X here versus the pizza, they kind of both look like they're the same size, but the positions had to be slightly different because the emoji takes up sort of a different amount of space, and that's just experimental with this Y value. And then I have different, let's see. Yeah, so this is where I make the materials, and then you have to make what's called a dynamic texture for these X's and O's. That's how you get the text onto the mesh or onto the material. Is that you create a dynamic texture. So down here, I had three different functions, but then I just made a generic get material function, which kind of covers all three, and then I deleted a lot of duplicate code. So you create a standard material, you create a dynamic texture, and then you assign that dynamic texture to your material that you made as a diffuse texture. And then I have this draw text function for adding it to the correct box, or adding it to the box, adding if the X or Y values. Sorry, having a hard time talking. And then these are just the smaller functions for make texture box and make material. So this is how I create the material and how I create the dynamic texture. And then, like I was saying, up here in get material kind of combines those two things and gets the correct material based on what we pass in. Based on the color we pass in, it gets a white material, magenta material, or a yellow material. Yeah, so that's it for this project. I tried this different format today because I started to record this as one thing, but my hands really didn't want to type that much. I tried to record it as like a complete walkthrough, but like I say, my hands just really didn't want that. So if you found this kind of formatting more informative and you liked it more than the complete walkthroughs, let me know. If you didn't, also let me know in the comments, but if you just like the fact that we made this, give it a upvote. And yeah, that's it. Babylon.js, Tic Tac Toe. If you want to see more Babylon.js, also let me know. Thumbs up this, subscribe. Thanks for watching, and we'll see you in the next video. Take care. Bye.